All right, welcome to Notes 1.4. Remember, you can always pause this and rewind if you need extra time to write something down or if you want to see something again. Okay, again, we're going to begin with vocabulary because vocabulary is so very important. So let's talk about angles. An angle consists of two different rays with the same endpoint. We all know what angles are. That's the official definition. The sides of an angle are those rays. The vertex of the angle is the endpoint of those two rays, that common endpoint. It's the intersection, essentially, of the two rays. And we know that the intersection of two lines, two segments, or two rays is always a point. And then the measure of the angle is equal to the absolute value of the difference between the real numbers for ray OA and OB, if we're dealing with angle AOB. And you'll see what I'm talking about in a second. This is just our official definition. All right, let's talk about some more stuff that you guys probably already know. There are different kinds of angles. We've got acute angles, which are angles that measure between 0 and 90 degrees. Don't tell me that an acute angle measures less than 90 degrees. Tell me that it measures between 0 and 90 degrees. A right angle measures exactly 90 degrees. An obtuse angle measures between 90 and 180. So don't tell me that an obtuse angle is greater than 90 degrees, because this is our exact definition, between 90 and 180. And then straight angles are angles that measure exactly 180 degrees. Just like we had congruent segments, we've got congruent angles, which are angles with the same measure. And just like we had a midpoint, which divided our segment into two congruent parts, we have an angle bisector, which is a ray that divides an angle into two congruent angles. So it's not just that it divides the angle, it's that it divides it into two congruent parts. Let's talk about how we name angles. We can name angles in a couple different ways. The first way is to use three letters. It's critical that the middle letter is the vertex, right? And then the other two letters are points on either side of the angle. So for example, this is angle ABC or angle CBA. B is always the middle letter. B, B. All right. If there's just one angle coming from a vertex, then you can name it with that single letter. So this could also be angle B here. Or if there's a number inside that doesn't have a degree marking, then you can also name it by the number. So this would be angle 1. All right, but if we have multiple angles going on from the same vertex, and these should have arrows on them, then we have to name them with either the three letters, so ABC, CBA, ABD, DBA, that type of thing, or we could call it angle 1 and angle 2, but we can't name any of these angle B because there are two angle Bs. In our previous lesson, we had a segment addition postulate. Well, there's also an angle addition postulate. So if B is on the interior of AOC, meaning just B is in the inside of that angle, then the measure of angle AOB plus the measure of angle BOC is going to equal the measure of angle AOC. So notice how I put this little m in front. It's because I'm talking about equality and I'm adding. And if I need to add two angles together, then I have to talk about their measures because I can only add numbers. And therefore, when I'm talking about the measure of the angles, then I have to use the equal sign because I'm not talking about congruence anymore. I'm talking about their measures. All right, and then furthermore, if AOC is a straight angle, then the measure of angle AOB plus the measure of angle BOC is going to equal 180 degrees because that's what straight angles equal. So I'd like you to go ahead and pause here and use that angle addition postulate to find me the measure of angle TSW in both of these cases. Okay, so you should have found that the measure of angle TSW in the first case was 75 degrees, and in the second case was 65 degrees. Make sure you include your degrees because that is the units for this answer. But again, we're not going to make it that easy. So here we have a case where GEF, angle GEF here, is an algebraic expression. It's 90 minus x. And DEG is also an algebraic expression, 6x. And then because DEF all lies on a straight line, this is a straight angle, which means that I know if I add these two guys together, they must be equal to 180 degrees. So I'm going to add 6x plus 90 minus x, and that's going to be equal to 180 degrees. So 5x equals 90, which means that x must equal 18. I'm pretty sure that's right. All right, so x equals 18. So we found that one. But again, that's not my final answer. It wants to know what DEG equals. So I have to plug it back in. DEG is 6x, so 6 times 18, and I get 108 degrees. All right, you guys pause right here, and you find me these two. All right, in this case, x equals 22, and since GEF is 6x minus 20, oh wait, we're talking about DEG, 2x plus 24, so 2 times 22 plus 24, so that 44 plus that, so we get what, 68 degrees? Sounds good. This concludes notes 1.4. There are some constructions that you need to know how to do, so I would like you to go ahead and watch the construction videos made by Mrs. Bentz, and come to class tomorrow prepared to do some more constructions in class. Thanks.